Welcome to our 5-part video series, where we'll guide you through the complete process of building trading signals, the main objective of this Datathon. We'll release the Jupyter Notebook a few days before the event so you can follow along. Throughout these videos, we'll show you how the notebook works and how to use it to build your own trading signals. We'll start with an overview of the process, then dive into more detail in the following videos. We're aiming to build a model that predicts stock returns by using the provided datasets for our independent variables, XVARs. The target variable, residual returns, is found in the residual returns file and will be explained in more detail later. The model's predictions will drive the formation of a long-short portfolio, which we'll evaluate using 5 metrics: Sharpe ratio, returns, maximum drawdown, up-down ratio, and dollars traded. Let's begin by exploring how your model's predictions translate into daily portfolios. For each trading day T, for example, January 3, 2017. First, start with predictions. Gather all of the model's predictions, or YPREDs, for each stock on day T. Then, subtract the median. Find the median prediction for that day and subtract it from each YPRED. We'll call this result X sub IT sub DMD. Now, we'll assign weights to each stock. For stocks whose X sub IT sub DMD is positive, meaning those stocks whose predicted returns are above the median prediction, the weight assigned is simply the median prediction divided by 2 times the sum of all the positive X sub IT sub DMD. For stocks whose X sub IT sub DMD is negative, meaning those stocks whose predicted return is below the median prediction, the weight assigned to each prediction is the negative of the median prediction divided by 2 times the sum of all the negative X sub IT sub DMD. These weights correspond to the daily portfolio allocations. So, how do we arrive at these weights, or signals? Let's break that down next. To generate stock return predictions, we first need to transform the provided datasets and then build a model to forecast future returns. We start by cleaning, structuring, and merging the raw data. This ensures a consistent format and allows us to create features that can help predict future returns. Next, we derive new variables, features, that capture predictive signals for each stock on each date. We store these features in columns, with each row corresponding to a unique date and stock pair. We also include the target variable, future stock returns, in the same data frame. Once our dataset is prepared, we split it into 2 parts: a training set, containing both the X features and Y target variables, for fitting the model; a prediction, or test set, where the trained model uses only the X feature variables to generate predictions of future stock returns. By following these steps, data preprocessing, feature engineering, and model construction, we're able to forecast stock returns and ultimately build the daily portfolios discussed earlier. When building the model, timing is critical. We must ensure there's no look-ahead bias by avoiding any overlap between the training and prediction periods. Here's a sample timeline for predicting returns in January 2022 using a 1-year training period. Let's say you want to predict for the period January 1st to January 31st, 2022. With 1 year worth of training data, we will use January 1st to December 31, 2021. But since we want to predict future returns, we must also leave out a few trading days at the end of the training period. For example, if we're predicting the next 5-day cumulative returns, we need to skip the last 5 trading days of December 2021. We exclude the last 5 trading days, which is December 30th down to December 23rd. Hence, our actual training period ends on December 22nd, 2021. Over time, market conditions change, causing model drift. To address this, it's best practice to periodically refit the model with new data while using the same parameters and pre-processing steps. In this timeline, for predictions in January, February, March, and April 2022, the training window simply shifts forward for each month, and you train a new model accordingly. 4 models in total for those 4 months. This concludes our overview of the modeling process. In the next videos, we'll dive deeper into the specifics of model building, exploring various techniques and best practices to help you create a robust model.